Well, good afternoon, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 15 is on the screen. It's only 3 itty-bitty problems. Let's see how you do with those. And, yeah, and today we're going to actually already get started with our book. How about them apples? Let's go. Let's go. So everybody has their book at home, yes? Yeah? So make sure tonight's HomePlay is going to be from the book, so I'll give you that in a little bit. All right, I'll give you some time for that. Copy and go. All right, get us started, please. Number 1, Zach. Measures. Mean, median, and mode. Oh, let it go. There it is. Mean, median, mode, yes? And once again, what symbol do we use for mean? Tell your neighbor, please. Yeah, X with a line above or the bar, yes? All right, does everybody know what I mean? Yeah? Okay. Number 2, with that said, what's the mean, median, and mode of this data? Jet. The mean is median, mode. That is correct. Let's go. All right. So it says number 3, write an equation to the best fit line. That means we first need a best fit line, yeah? So let me draw the best fit line. Oh, sorry. Is that a best fit line? No, by now we should know that it has to go through the data and following the correlation, so somewhere like that, yes? However, try to intersect at least 1 or 2 points, so can I move this a little bit? Something like that, yeah? All right. All right, tell your neighbor your equation, please, that you came up with. What was your equation? All right, Jet, pass someone. Plus 2. Okay. I'll take that because his scaling might have been off, a little bit off the mean. Was some of yours off a little bit? Yeah? Some of you? Okay. How about 3/4 x? Yeah? How about 1 over 1x plus 2? Plus 1? Okay. Yeah, it depends how you drew the line. I'll take any of those. I just want to make sure that you did the work. All right, move on. Next, agenda for today, warm-up number 15, statistics and probability. Today, once again, we're diving straight into our text now. Today, we're going to be clarifying some more terminology. And I don't know if you noticed, like, it seems like everything we've done up to right now in regards to statistics, it's more basic stuff, right, with data. I'm giving you plenty of practice with standard deviation because all year we're going to be dealing with standard deviation, but the only thing we're going to be adding more formulas to that as we go along. But other than that, today the terminology that we're going to cover, it's pretty abstract, and it's more of a clarifying what kind of situations they give us and what kind of data are we going to be looking at in regards to some of the stuff that we're going to be seeing with studies or census. Okay? So your home play for tonight is from your textbook, page number 5. You're only doing numbers 1 through 16 only, but only the evens. So that's how many? 8 only. Okay. All right. We good? All right. So over the weekend, you had no home play. And there is no near-pod code. And once again, page 5, numbers 1 through 16, events only. All right, get a Cornell note ready, please. If you have your colored pens or highlighters, have those ready because we're going to be looking at certain terminology to clarify stuff. Copy that really quick. I'll give you some time to set up. So our objective for today, I can differentiate descriptive and inferential statistics. I can differentiate descriptive and inferential statistics. I can differentiate descriptive and inferential statistics. So our main concept, we're still on statistics, but today we're going to be a little bit more thorough with it. And we're going to be talking about two types, descriptive and inferential. And I want to make sure that before you leave today, you understand which one is which. That's what differentiate means, okay? So, statistics, definition. The science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. The science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. As you're copying that down, think about this. Haven't we been doing a lot of stuff with different graphs and different types of devices? And what is the question at the end that I ask you? What is your conclusion, right? So from whatever it is that you observe, you have to come up with a conclusion. That's using statistics. The science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. So let me show you 4 different examples of what we've been doing so far in regards to statistics. So we've been using bell curves to display data, yes? About coordinates and best fit lines, yes? About frequency tables, yes? About box plots, yes? All of this, guys, these are just tools to represent what? Data, also known as statistics. And do we use all of these to draw conclusions? Yes. You need to use those devices to draw conclusions. Now, do you need to copy all these examples? No, just copy one or another, just so you can have an idea as to what we've been using in regards to drawing conclusions from. All right? Now, is that pretty clear in regards to statistics? We've been using what? A lot of organization, summarizing, analyzing, but at the end we draw conclusions from data, okay? So let me show you an obvious non-example, those of you that were with me before. Let's see if you remember these. Functions, yes? Are we going to be transforming functions? No. Just draw one or two of those just so you can have as a sample as to what we're not going to be doing. We're not going to be transforming stuff. We're not going to be deriving formulas and such. We already put that baby to sleep already, right? Unless you guys want to, revisit some of those, just let me know. You're like, no. All right. So, what is statistics? Well, hashtag. Well, science. Whoa, that moved. Hold on. Let me go back. Hold on. Anyways, hashtag science, hashtag studies, and hashtag data conclusions. That's what we've been doing. That's what we're going to continue doing. The only thing is going to get a little bit more elaborate. So just we're going to go like this really quick. Bear with me, yeah? So FYI. All right. So let's see if this goes. Yeah, all right. So we know what statistics are. we're just revisiting. When we first started this road into statistics, we talked about data. You already have these notes. It's just a recap. And data, we said it was a collection of facts, of information, to calculate, analyze, and plan something. And we said that there's two types of data that we were using. They were categorical and quantitative. You guys remember that? And I said, categorical are the ones that cannot be expressed by numbers. So it's just categories of things. Whereas quantitative are what we can express with numbers. For example, categorical could be your favorite color. Whereas quantitative could be what? The winning lotto numbers? Yeah, because it involves numbers. So if I was to ask you for that, let's do this really quick. You don't have to copy this, but here it goes. If I was to ask you for your favorite color, you would say what, Jet? Go.
Purple.
Purple, okay. All right. My favorite color is red, black, and white. Zach, yours? Black, okay, sorry. Nick? Black, oh my goodness, okay. Aaron? Black, oh my goodness. Medi? Pink, okay. Pink or fuchsia? Okay, all right. And so on and so forth. So when we start collecting data like this is known as a data set. Each part of the data set is known as a data value. Once again, the entire data collected is called what? Data set. But each individual one is called a what? Data value. So do me a favor, just write favorite color, write a couple of these, write data set, and then just point to one of them, circle it, and call it data value. Now let me look up the winning lotto numbers. Let's see if, actually I'm not going to look for the winning lotto numbers. I'm going to look for the last Super Bowl drawings, which were September 17th, this Saturday. The numbers that they drew were 5, 25, 36, 51. Man, that fan's loud, right? 61. And the Powerball was one. All right. So, please your neighbor, let them know what this is called. Data set. Yes. Okay. Next, tell your neighbor what this one is called. The data value. Yes. Now check this out. Who's seen? Has anybody sat down to see when they draw the numbers for the lotto? Or have you seen that in the past on videos or something like that? Okay. Do they just go like, okay, they already have the order and they get the numbers, or is it random? It's random, right? So when they do random, that's what they call a random sample. Yes. Mm-hmm. All right. Now, these were the last ones from Saturday. Today's the next drawing, Monday. And for parents, if you're going to watch this video with your kids in regards to statistics, tonight, Lotto or Super Bowl, it's all the way up to 238 million. So there you go. 238 million if you hit the Powerball. So anyways, that's today. So I might go buy one. $1? It only takes $1, right? $2? Oh, okay, $2. I don't pay a lot of that much. So. Anyway, yeah. Anyway, all right, let's move on. Next, let's see if you recognize this. This. Oh my goodness. Give me a second. All right, here we go. Let's see if you recognize this. Have some of you been to Costco? Yeah. Or sometimes they do that at Vons or at other places. What do they call this when they have somebody there at the end of the aisle? What is that called? A sample. That means they are only taking a little bit of something that they sell for the entire store. That little bit of something is called a sample. In statistics, the same thing. When we only get something small from a bigger amount is known as a sample. The big amount is known as a population. It doesn't matter if you're talking about people or not. The entire amount is known as a population. For example, she's giving samples of, it looks like, what is it? Sea chicken? What is it? It says Vienna sausages. So imagine they have like a whole pallet of Vienna sausages in cans, right? Now, is she going to give all the cans away? No, that's called a population. Is she going to give out the population? No, she's only going to give out a what? A sample. That's as best as I can introduce you to what we're going to be looking at in regards to data through the entire year, okay? So, with that said, copy this one, please. Example 1. Example 1 reads, census, in parentheses, data collected from every subject. On the first one, it says, students at Imperial High were asked for their favorite food. On the right side, it says, students that eat lunch from Imperial High were given vote priority for their favorite food. Okay. Underneath that, draw, if you can, this. Doesn't have to be like elaborate like that. So as you're copying that, here it goes. It says, students at Imperial High were asked for their favorite foods. Here's the entire population. Now I placed an L on some of them because only those are the ones that eat lunch from Imperial High School. So I'm pretty sure some of you, you guys know people that maybe bring food from outside in, yes? Some of you, yeah? Okay, so then it says, students that eat lunch from Imperial High are given vote priority for their favorite food. So that means, am I going to use the entire population for this second situation? No, I'm only going to use those with the letter L, or the ones that eat Imperial High lunch. Underneath that, I want you to draw this Venn diagram. So, first situation, I'm going to label it A. Second situation, B. The shaded part of the Venn, that's known as the population. This section in here is known as a sample. So, which letter corresponds to which? Talk it over to your neighbor and place your letter where it belongs, please. Students at Imperial High were asked for their favorite food. Students that eat lunch from Imperial High were given vote priority for their favorite food. Talk to your neighbor. Let them know which one's the population and which one's the sample. Population, sample. All right, population. Amy, go. Hands, have you got that? Yeah, because it's the entire population for Imperial High. Yes? That means that those that, the ones that only eat lunch here are what? B, which is a sample from the entire population. Okay? So, from 1 to 5, how comfortable are you with that so far? Yeah? 5, 5, 5, okay? First part of the HomePlay is going to be, they're going to give you situations, and you need to figure out which one's a population and which is a sample. Let's do another one. Copy this, please. Example 1Q. And it reads, situation A, total voting residents in the city of Imperial. B, total residents in the city of Imperial. I'll give you some time to copy that. Once again, label the Big Bend population. And the smaller one is known as what? Sample. So place your letter where it belongs, please. All right. Talk to your neighbor, let them know which one goes where. Which situation is the population and which is the sample. All right, good conversation. So let's see, Mehdi, which one's our population? B. Hands if you agree with it that it's B. That is correct, B, because it's all the residents, including the little babies to the adults. Yes? That's the entire population. That means that only those that vote, which are the adults, are our sample. A. Okay, from 1 to 5, how comfortable are you with this? Yes? All right. Let's do one more just to make sure we got this. Example 1 Super Q. And it reads census again. The first one is all City of Imperial Police personnel. And B, all City of Imperial Police personnel who drink energy drinks. All right, tell your neighbor which one's which, please. I think JC's got this one. Which is the population, JC? A. Hands if you agree with that. Let's see. All City of Imperial personnel. That includes those that drink energy drinks and those that don't drink energy drinks. So yeah, that's the population, which means the sample is only going to be those that drink energy drinks. Okay? All right, from 1 to 5, how comfortable are you up to right there? Okay. Now, I hope you're noticing the difference between the mathematics we used to do before to where we're going with it. This is a little bit more abstract, and you need to be understanding what we're looking at, okay? All right. Let's move on your notes. Draw a Venn diagram, please, because we're going to be talking about two types of data that we're going to continue with in statistics. We're going to be talking about descriptive and inferential. Descriptive and inferential. You're like, what? Yeah, descriptive statistics and inferential statistics. Now, the word descriptive comes from the root word describe, and everybody knows what that is, right? You're given facts, or you look at facts, and you just describe what you're looking at. Whereas the word inferential comes from the root word infer, which means you come to conclusions in regards to some of observations or maybe hypotheses or maybe tests that you do. So, what do all these have in common, these two? Well, they both have data collection and organization. You have to collect data. You have to organize it. However, descriptive statistics, you have to summarize with facts by presenting what you came up with from data. They're facts. Kind of like if I was to take a survey from here and I would say, okay, raise your hand those of you that have iPhones. Let's see, do that really quick. Those of you that have iPhones, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Those of you that have Samsung type of phones. 1, 2, 3, 4, 5 of us, okay. Yeah, I'm more of a Samsung type of person, and the rest of you have rocks and chisel. Communicate with rocks and chisel, yeah. So anyway, when I give you data using that information, that's descriptive because I'm just describing what I'm looking at. It's raw data, and it's just giving you the facts. Okay, so what is inferential? Well, let's find out. Estimations, hypothesis tests, and making predictions. For example, from the grades that I just turned in, this is Mr. Q, I'm predicting that all of you are going to pass with an A this class. So far where we're at so far with grades. What am I doing? Am I giving you just plain facts? No. I'm actually trying to predict that you are going to pass because of what I've seen. Okay? But I'm making a prediction. Or, in other words, a hypothesis from observation. Okay? So, with that said, I'm going to give you a situation. You need to tell me if it's just a fact presentation or if it's a prediction or an estimation. So you need to tell me if either it's a descriptive or an inferential statistic. Okay? So don't copy this. Here it goes. I'm going to leave the little Venn diagram on top. I took a little screenshot of it. Here it goes. It says, name the statistics being used. The average price of a 30-second ad for the Super Bowl is $2.5 million. Talk it over to your neighbor. Let them know if this is descriptive or inferential. What do you guys think? Let's see. Did I pick JC already? No. No? I did? Pass it to someone, JC? That was good. That was good. Pedro, what do you think? It is descriptive because it's a fact. That's how much they sold it for, and that's what they're going to sell it for in the next one. So therefore, this is descriptive. So copy that one and write underneath descriptive. Example 2. Name the statistics being used. I'll give you some. All right, so we said this one is what? Descriptive. All right, and this is descriptive stats. Okay. All right, look at this next one. Don't copy this next one. It's just for you to know. And then we'll go to the next one. You'll copy the next one. Here it goes. Example 2Q. The State of California Air Resource Board predicts that by the year 2035, the state will only sell electric vehicles. Talk about your neighbor. Let them know which kind of stat this is and why. All right. Pedro, pass someone. That is correct. Inferential. Hands, have you got that? And why did you choose inferential? That is correct. It says here that they're predicting. Even though they are trying to get a law in or a bill in so that by the year 2035, that's all they want to sell. But that's, I don't want to get into that, but have you guys seen that they cut off the power in the summer from time to time? Yeah, here in California, they do selective blackouts, that's what they call it, to save energy. So how are you going to charge your vehicles if we go all electric if they're going to cut the energy? So anyways, that's neither here nor there. All right, look at this one. Example 2, super Q, and it reads, a medical report states that taking statins is proven to lower heart attacks. It is proven, okay? But some people are slightly high risk of developing diabetes when taking statins. So be careful with this one. Talk it over your neighbor and let them know which kind it is and why are you saying that. Which kind that is and why you're saying that. Nick, oh, Aaron. Thank you. Thank you, sir. Looks like Patricia's got it, Valeria's got it, Melissa's got it, very good. Lynn's got it, yes. Vince, pass them on. Melissa, what do you think? Descriptive or inferential? That is correct, inferential. Now let's why. Let's think why. Up to right here is a fact. Is that correct? However, they include a comma, and it says that some people are slightly high risk. That means that they know that they're predicting that some people are going to develop some kind of illness. So they're making a prediction with some of that data. So it is inferential. All right, here goes one more. All right, tell your neighbor, it says a survey of 2,234 people conducted by the Harris poll found that 55% of the respondents said that excessive complaining by adults was the most annoying social media habit. Tell your neighbor what kind of statistic this is. All right, everyone on 3, 1, 2, 3. Descriptive, that is correct because it's facts. They're numbers and they're just giving you the facts back to you. So, Before we leave, you have one descriptive. Copy this one. This is an inferential, so you can have it as a sample. And your HomePlay, that's basically it, guys. They're going to ask you to define certain things that we covered today, and they're going to give you 4 situations so that you can look at them and say which one is which. Is it inferential, is it descriptive, or what? Okay? And I'm going to stop the video right there. Once again, I'm trying to upload this before I leave, if not later on tonight. Okay?